Okay, let's recap what we have done so far. As you've seen, it's been a pretty long segment, the very first segment of Fourier series, but the goal was make a Fourier series expansion, which means that it is going to be involved with the cosines and sines, trigonometric functions, and the final f of x expansion is going to look like this, all right? So you can see it goes to infinity. So I have a0, an, and bn. So my goal was to find the Fourier series coefficients. And the first thing is I take the integral of both sides, that the equation that you're looking at, and I take the integral from minus p to p and with the variable of dx, and I was able to find my a0. I'll show you, okay, in a moment. Then I went ahead and multiplied both sides of this equation by cosine of m pi x by p, okay, and I get myself then this an value, all right? And you've seen, let me show you it. A0 turned out to be this box type equation right over here. And for an, as I said, I multiply by cosine m pi x by p, and when it's all said and done, you will see that this whole right hand side turns out to be a p. So that was fairly easy, an times p. So then I got myself an, this fairly nice formula. The only thing that is left over here is the bn value, right? So far I haven't found that. Once I find that, I'll be so happy, okay? For the an, I multiply by cosine. So now I'm going to do the same thing, except I'm going to multiply by m pi x by p minus p to p f of x times sine m pi x by p dx will be equal to a0 by 2 minus p to p sine m pi x by p dx plus summation from 1, not 0, to infinity, an, because a0 is here, this term is a0, times minus p to p cosine of n pi x by p times sine m pi x by p. That's what I'm multiplying with, right? And then let's do it in parentheses, plus bn minus p to p. This time it was sine n pi x by p. This time around, I'll multiply this by sine as well, n pi x by p dx, right? Okay. Oh boy, that's a lot to do here. But let me do something though. I did this before. When I did that, you can see your previous, segment, you get this 0. Okay, so I'm not going to rehash this again. Also, this is the nice thing about it. In the previous segment, I showed you that when I multiply sine and cosine, it was identical to this. I showed you that this is going to end up with 0. Nice, not too bad. Okay. Again, I'm referring to the previous segment, so you must watch it to understand where is this coming from. Okay, or you can try it yourself. But then what happens is then I'm left with this is equal to that, right? So the only challenge that I have here is I want to find this. What is this? Once I find this, I plug it in, I go ahead and find my bn value. Let's close the parentheses before I forget. Okay. So let's look into that particular term. That is the one that is seeing like a problem for me. N pi x by p times sine m pi x by p dx. Okay. You know what? I'll take a shortcut. Again, I would like you to watch the previous segment for this, okay? I've shown you the case for cosine, okay? I showed you the cosine, but now this is sine. The equation will look a little bit different, but when I get m is equal to not n, and the cosine case I get 0, in this one I'm gonna get cosine, same thing, I'll get 0, okay? In the previous case, when m was equal to n, then I got myself p, okay? And I'll get the same here. So I will not be able to demonstrate this to you because I have demonstrated pretty much everything so far, okay? So that's your responsibility to just go out and find this out, okay? But at the end of the day, what will happen is I'll have an integral. I will have minus p to p, basically the left-hand side. It's going to be f of x times sine of m pi x by p dx will be equal to bn times p, okay? So it's coming from here, 0, where m is not equal to n. The only thing that stays here is when m is equal to n, so you can see p, okay? So now, basically, from here, I can go and write my bn value. So then bn will be equal to 1 by p, let's not forget that, integral from minus p to p, I got myself f of x times sine n. Okay, wait a second. Maybe I make a mistake. I'll ask you this question once I'm done. Well, I put n over here. This was m. What's going on? Well, look here. If m was different than m, it's going to be 0 anyways. The only case where it will not be 0 is m is equal to n. So I can use them interchangeably. And I used n for, obviously, right here, right? an, bn, an. So I don't want to use another letter to confuse everybody, okay? So that's what I'm going to end up with at the end of the day. So this is my bn value that you're looking at over here. So just to recap, go back. I have find my, this is where I started with. Wow, that's been a long segment. Here, this is what I have, right? This is what I started with. And I first started with a0 in the last segment, and I find it the boxed up equation. Then I went to the an. You can see that is the boxed up equation. Wow, that was long. This is an. Then I did the similar approach for bn, and I got myself bn value. So next what I'm going to do is I'm going to write everything in a neat form, because you will need to refer to that, okay? So I'll be right back. So let's write it in here. As a result, Fourier series for f of x in, remember that, the interval minus p to p was the interval that I have, is given by. I want to write this nicely because this is where you're going to use this version. F of x is equal to a0 by 2 plus summation sign n is equal to 1 to infinity an times cosine of n pi x by p plus bn sine n pi x by p. Okay, so this is the original equation that I write, where a0 now 1 by p integral minus p to p f of x dx. An is equal to, again, 1 by p minus p to p f of x times cosine n pi x by p dx, and bn 1 by p minus p to p f of x times sine n pi x by p dx. Okay, I'll give you a hint because you're going to memorize this. You need to memorize this for my exams. So your an value, looking at an, right? So you see a cosine here, and this is a cosine, you see? And this is the same thing, n pi x by p, right? Same thing for the bn. So it's not that, at first instance you may see this is a bit of a hard thing to memorize, but no, not necessarily. So I'm going to cut this segment short, and I'll be back with an example on how to do this, okay? Thank you for watching this. Take care.